Hello and welcome to this continued lecture on functions in R programming. So here's a function with 4 arguments a, b, c and d. So a has no default value. B, c and d all have default values. And so when you define a function, you want to both specify the names of the arguments and whether or not any of the arguments have default values. So null is a common value to assign to an argument, which can mean a variety of things, but usually mean that there is nothing there. So one of the key features of the R language is what's called lazy evaluation. So lazy evaluation is a common model in a variety of programming languages, and the way that it works is all of the arguments to a function are only evaluated as they are needed. And so for example, if you take a look at this function over here, you can see it takes 2 arguments a and b, but the body of the argument only takes one thing. It takes a and then it squares it and then it returns it. And now recall that in a function, the return value is whatever the last expression is evaluated. So there's only one expression in this function. So that's the last expression, and so it's the return value. So if I say f of 2, what happens? Well, in R, what happens is you get 4 because 2 squared is 4. Now you might be wondering what happens to b when I call f of 2. I never specify what the value of b is, and furthermore b doesn't have a default value, and so what happens is nothing happens because the function f doesn't actually use b, and so the argument is never evaluated, and so because it's never evaluated, there's really no error. There is nothing that's going wrong here. Now you might say there, of course, well, the function f is kind of poorly defined, that why would you give an argument that's never actually evaluated? So, and that's a reasonable objection, but in this case the function will operate correctly only because of the value of 2, which is positionally matched to the argument a, which is then squared. Here's another example of a function that's only slightly more complicated than the previous one. So this is another function that takes arguments a and b, but now what the function does is it prints out a and it prints out b. And so when I call f of 45, look what happens. Well, I get an error that says argument b is missing. So here what happened is that it printed out 45 because 45 was matched to the argument a, and so there was no error. Up until the first line of the function, there was no error occurring. But then when it got to the second line, it had to evaluate the argument b. And because b had no value assigned to it and no default value, then an error had to occur. So here you notice that the error only occurs after the 45 was printed out, and so the lazy evaluation applies. But because the argument is only evaluated when it's needed, everything else comes before it that's valid. It will evaluate it until it hits the part that causes an error. So there's a special argument in R functions which is the ... argument, and it is used to indicate a variable number of arguments that can sometimes be passed on to other functions. So the 3 dots are often used when extending another function and you don't want to copy the entire argument list of the original function. So for example, you might want to extend the plot function just to have a little bit of a tweak or to change some of the defaults. And so for example, you might create a function that's called myPlot, and the myPlot will replicate some of the arguments of the original plot function like x and y, but it's going to change the default type arguments so that instead of creating circles for points, you want it to create lines. So you say type equal to L. So but of course the default plot function has many other arguments, and you want to leave them all ultimately the same. And so what you can do is pass ... and then though that can be used to kind of absorb all the other arguments in the plot function. And then what happens is I'll take the ... and then pass it down to the original plot function, and so all those original arguments can be preserved, and then I don't have to retype or reconstruct all of those arguments in my extended function. There is another use of a ... argument, and it's for what are called generic functions, so that extra arguments can be passed to the methods. So we will talk a lot about more of this later when we talk about objects oriented programming. But the basic idea is that in R, there can be special functions called generic functions, which don't do anything, but what they do is they dispatch methods to put according for different types of data, and so the dot 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 is used very heavily in this type of setup. Lastly, so the dot 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 argument is necessary when the number of arguments that are passed to functions cannot be known in advance. So one good example of this usage is in the paste function. So the paste function, what it does is it concatenates a set of strings together to create one string or a vector of strings, and it can take a variable number of arguments. So there is no way for the function to know in advance that how many arguments it's going to have to paste together, and so the first argument for paste is actually dot dot dot, and therefore you can take a number of different R objects that are character vectors and then paste something together using a separator, and in which case the default is the space. So there are other arguments to phase which are set to collapse, but they come after the dot 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 argument. Another function that has the dot 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 as the first argument is cat, and what cat does is similar to paste. It pastes together a number of strings, then it prints out the concatenated string either to a file or to a console. So you can see that there are many other arguments to cat, but the first argument is going to be the set of R objects that are going to be concatenated. So one catch with the dot 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 argument is that any arguments that appear after 3 dots on the argument list must be named explicitly, and furthermore cannot be partially matched. So you cannot use positional matching or partial matching for arguments that come after the 3 dots, and this kind of makes sense because otherwise there's no way for R to know whether you are passing something to the dot 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 or whether you are passing something to a different argument. So if I say in the first example here where I try to paste together A and B, so A and B are going to the dot 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 argument, and then I say sep equals colon, and then which means that I want to paste something together by separating them with a colon. However, if I try to do partial matching with set, what happens is that the partial matching gets ignored, and so when I say paste A, B and then SE equal to colon, well, the SE in another circumstance might be partially matched, but in the paste function it cannot use partial matching. So it just ignores that and just assumes that colon is just another string to be pieced together, and so then you get the string AB colon. So just be careful when you are using functions that have dot 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 as an argument, that any arguments that appear after the 3 dots have to be named explicitly and in full. So that's it for today. See you in the next lecture.